right, let's continue here in GIS Basics, Section 1, Part 2. So when we last left each other, we were looking at just the broad picture of map making. And first of all, we talked about what a map is, how a map is made, who's collecting this data, and then what is a GIS? So we've been using this term as an abbreviation. What does it stand for? So GIS stands for Geographic Information System, or Geographic Information Systems. SYS. Okay, and so what we're looking at here with a GIS is a system, and in general what we're talking about here is a software system, so something that we apply on a computer, a software system that is used to collect, to hold on to manipulate, analyze, change, manage any type of geographical data or spatial data. So when we talk about that, the key is that the data is spatial, that there's a geographic component. So that could be something as simple as a list of addresses. So if you've got a name and you put it with an address, now you've got a piece of geographic information or spatial data because we have a location. If you've got a bunch of plot center points that you used for maybe some bird survey work, each of those points is a piece of spatial data, and maybe attached to that data is like the point, and you have a list of the number of species that you heard while listening from that point for like a bird survey, right? And that data associated with the geographic piece is known as attribute data. So an attribute is like a characteristic of something. So attribute data is a characteristic of our spatial data. So when we have a geographic information system, we're working with data that has a location and then some attributes. So additional information about each of those spatial features. So really, that's what makes GIS powerful. That's what means that we can do stuff with it. I mean, it's one thing to have a map and to be able to sketch things on it, right? Oh, that's fun. I can draw. I can put a point where my house is. I can put a point where my survey information, where my surveys occurred, and that's nice. But what makes GIS powerful is you don't just have that point, you have the information behind it. And we'll take a look at that attribute data shortly. But that's really where the rubber starts to hit the road, where you start to be able to do things that are powerful here. So let's kind of back up here. So data is going to be just information, right? So data is, and if we could spell, we'd get it right, information. So as technicians, that's a big piece of our life, of our work life, is data. We're collecting information, and it might be information on the plant species found in a location. It might be information on tree diseases or insects we're catching, and maybe we're looking for pine beetles, and we've set up a bunch of collection traps, and we see which types of beetles are collected in each trap. Maybe we're looking at hydrologic information. We've got wells, and we've got the depth of water in those wells. So technicians' bread and butter is data, and learning to collect it well, to work with it well. So spatial data is that information, but it's going to be information with a location component, and that could be as simple as an address. It could be a latitude and longitude. It could be UTM coordinates. Then geospatial data is going to be information with a location referenced to the globe. All right. So spatial data could just be an address list, but geospatials can be put on a globe, put on a map, and that's the kind of data that we're going to be working with in this class. So kind of the hierarchy of data here. I wanted to take a minute to just show you how ArcGIS Pro meets those requirements of being a system designed to capture, store, manipulate. We're going to look at some of the features here. If you've got the workbook printed out in front of you, you can just sketch on it with a pencil, right? But if you're dealing with it digitally like I am here, if you're in Adobe Acrobat and you're in the comment, if you click on comment and this right hand side menu, you should be able to use the sketching tools. And so I'm going to grab this pencil sketching tool here. This is the sketch color. I think red works all right for this. But I'll scroll down so I can make some sketches here, okay, just to kind of point some things out to you while we talk. So here's ArcGIS Pro interface, and we'll actually together pull it up and not just look at this picture in a minute. But I wanted to show you how you're working with this information. So we've got let's see, what did I want to tell you about? Capture, store, manipulate, analyze, manage. Okay, so we've got the storage piece, and that's over here. We're going to look in our catalog pane. So this is our catalog pane. Note the catalog here. And that's where we're going to kind of manage and move data around. We'll talk about that a bunch in the next section. Okay, so that's kind of that data piece. And as far as capturing geographic information, primarily we won't be doing that in this program. A lot of times that's done in the field with Avenza or with a handheld GPS. But sometimes we'll actually sketch things on a map. This map, we just see a little segment of it, and what we're looking at is we're looking at pieces of the Kootenai River as it heads from Bonners Ferry up into the reservoir that's outside of Nelson, BC. This is just a little segment that crosses the border. Bonners Ferry is down here somewhere. But if you were to draw something on a map, you could create geographic information that way, and we'll talk more about that in section 2. So that's kind of the collection of the information. And then the idea is that we need to be able to analyze that information and do things with it. And we're going to get into that. We'll have our analysis tab and our edit tab on the ribbon. So this up here is the ribbon, and this is the catalog pane. So when I talk about the ribbon, or instructions tell you to use the ribbon, we're talking about this piece up here. And then we've got the contents pane that we usually put to the left, and we'll play around with this shortly, but this contents is showing you the spatial data that's been put on the map. So in this case, we've got a paddle route and up the Kootenai River when we've got days planned out what you'd be doing paddling here. And we've got land ownership here. And so you've got this geographic information. So basically, it's information as a spatial component. You've got a day, and then you've got a segment of the river that you'd be paddling. And then you have parcels, and you have their ownership. I think here we're mostly just, we've got a couple provincial parks, and then we've got Forest Service land. So you've got not just the location of something, but you actually know something about it. For example, and then this here is the attribute table. And so we'll talk a little bit about this. I'm not very good at attribute. So that's our attribute table here. And it gives you information about the features that we've put on the map here. So in this case, we've got the days of a paddle trip all in one feature class. And so each of these days represents one feature on the map. They're kind of in these lines here. And then you've got information about those, the miles, the number of miles that they are, each of these segments that make up the days. And so the attributes table has information about these locations, and that's where the power comes from. And certainly this is very simple. You could have a whole lot more information, and we will look at examples of attribute tables that have information about the features on the map. But the key thing that we wanted to talk about here is that this attribute data is what creates power in GIS. Okay, and then we have the spatial features. That's the geographic component. All right, so let me switch to writing here. That's better. All right, so what tools are we going to use? Well, back in the old days, everything, like pre-computing power, everything was physical, and cartographers, so cartographers are map makers, and cartographers would use tools to build maps, like some of these tools. You'd have tools that would help you transcribe shapes from and scale them up or down from one location to another. So you'd have lots of compasses and compasses and digitizers when we were kind of moving from that when we were crossing the boundary between paper map and digital maps, and now almost all maps are created digitally. So what tools do we use? Well, those are tools from the past, which I'm much better versed in our current tools. Just kind of wanted to show you and imagine making some of these maps, in decades gone by. But I want to look at this kind of the landscape of GIS today to help you see that there's more than just ArcGIS Pro, but that's kind of the top tool that we deal with. We've got a few different software development companies. So there's the Open Source Geospatial Foundation, there's Google, and then there's Esri. You're going to hear us talk about Esri a lot, which is why I want to bring it up now. So when the name is thrown out, you're not like, what are they talking about? So Esri, that's how we say this abbreviation. I'll tell you what it means in just a minute. But Esri is a software development company that develops the software that we're using right now. There are other software development companies, kind of like Microsoft makes Word and Excel. Esri makes geographic information system software. And so that's where we are. We're using ArcGIS Pro. There's also ArcGIS Online, and there's also ArcGIS for desktop, which is kind of it's kind of the older version that folks were using 5 or 10 years ago. The Open Source Geospatial Foundation, you might hear folks talk about QGIS or GRASS. So the Open Source Geospatial Foundation, they have those types of software. And then Google, I'm sure many of you have used Google Maps. You could do some fun stuff with Google. Right now, it's not as powerful and it's not as easy to use some of the more advanced tools as we get in ArcGIS Pro, but it does have some nice open source stuff. So Google Earth Engine is something that folks may use in modeling to take advantage of kind of some clustered computing capabilities. We've got Google My Map. Sometimes I use those just to make a quick sketch. We've got Google Earth. You guys have used those. But so these are the software development companies. Here's some of the software they make. We are using the Esri developed software, ArcGIS Pro, and then many of these software have specialized extensions that allow you to do extra things. For example, in ArcGIS Pro, we've got image analyst extensions, we've got spatial analyst, we've got 3D analyst, business analyst, and basically they open up some functionalities for you. So they're like add-ons to the software, and we'll use a couple of these, especially in our second class. But just trying to kind of point out to you that that kind of where we are in the hierarchy of things. So there are more than one geographic information system software. And a few different companies, and then some different software in there. But it is important to note that the ArcGIS suite of software produced by Esri is kind of the industry standard. So sort of like when you do word processing, you probably use Word, Microsoft Word. And it's kind of expensive, but pretty much everybody uses it. And if you're in school, you use it. And if you go on the job, you'll probably use it. There are other things like WordPad, or I'm sure Apple has some sort of proprietary word processing software. But the idea is that Esri kind of has mostly a monopoly, and ArcGIS Pro is the professional software that you are most likely to see when you leave school, if you're working for an agency or a private employer. So that's why we're training on ArcGIS Pro. But if you do end up in a situation where you're working maybe with a nonprofit that runs QGIS, or you're doing something in academics that's working with a Google software, the ideas that we're presenting here are transferable. So the concepts are going to be the same, the ideas of design, kind of what you're doing when you do analysis, and then you just have to figure out how it's a little different. But we're going to start with ArcGIS Pro because it's the most widely used software. Okay, so abbreviations, so that when people are throwing words out there, you're kind of getting it. To simplify wording, we'll often refer to ArcGIS Pro simply as Pro. Let's see if I've got this working again. Okay, no, let's see. I may need to pause and make sure I'm in the right thing here. Okay, that was easy enough. We'll refer to ArcGIS Pro simply as Pro. When we refer to ArcGIS Online, which is an online interface, it's becoming more powerful. So where you can do quite a few things in ArcGIS Online. Still, Pro is a little bit better, especially if at some point you want to output a printed document or like a PDF of a map. You just get a lot nicer layout in Pro. And so we're going to continue to work in Pro. But sometimes ArcGIS Online, that's AGOL. Okay, so those are abbreviations that you may run across frequently when we're just kind of throwing out jargon. But hopefully that gives you a feeling for the landscape. And back to Esri. What does Esri stand for? Earth Systems Research Institute. All right, so that's what Esri stands for. Everybody else always just calls it Esri though. And know that they are kind of, they've got the corner on geographic information system software. And they've been around since the 80s. So this software is old, but this latest version just came out in 2023, February of 2023 for ArcGIS Pro version 3.1. They update it about every 3 to 6 months. So how is GIS going to fit into your workplaces? So if today we're kind of taking a broad look at GIS and kind of this landscape, technicians are going to be ones that collect data, spatial data, also going to be doing things like quality checking data, also going to be doing things like processing spatial data, also going to be doing things like, in general, adding spatial data to standardized layouts. So maybe your agency has a standard way that they like the map to look, and they just say, hey, we just want you to add the data to the map so it looks like every other map. Oftentimes, you're going to be kind of, technicians work with data. You're going to be in there working with the data. Let's see. Yeah, so those are kind of some of the things you'd be doing as a technician. The ologists, like hydrologists, biologists, foresters can be called ologists too for these purposes, but they're usually the folks that are managing technicians, so they're usually the bosses of technicians, are the biologists who want the data, and so they're going to be kind of directing data collection. They're going to be directing the processing. They're going to be sometimes developing or guiding the development of layouts and design. And kind of doing that kind of directing stuff. And sometimes they'll be out in the field. Sometimes biologists will also be out in the field collecting data, but often they've got a few more administrative duties, and so they're kind of in and out of the office. Sometimes you'll have a GIS analyst or a specialist. Not every agency has this, or company, but someone who's a GIS analyst or specialist will usually have concentrated training in just that area. So they often won't also be a biologist. They'll just have kind of gone a GIS route or geography or cartography kind of degree. And so they're going to be directing kind of the big picture data management plans. They'll be like designing picture. They're going to be designing databases and storage protocols, that sort of thing. They may be troubleshooting system issues. They may be developing standard map templates. They may be doing some modeling for biologists or other ologists like geologists. They may be getting data from technicians. All right, and input. So kind of the higher level computer coding type of stuff is usually going to be a GIS analyst or specialist. What I wanted to point out though is, GIS has become less and less complicated, more and more user friendly. So in the past, like someone who was a technician really wouldn't get into the GIS because it would be sort of like coding and it would be really difficult and it would crash and it would just kind of be a pain, and they'd kind of leave that to the GIS analyst. That's not the case anymore. Really, today, most of our technicians, most of our biologists are also going to be working in GIS. If you're lucky enough to have someone on board who's specially trained, and you have a separate GIS analyst, they won't be like, let's say you work for the Forest Service, they're not going to be at a given ranger station. They'd be operating more at like the forest level, like the Colville National Forest might have one GIS analyst for troubleshooting and for modeling maybe and for setting up things, but generally on a day-to-day basis you'll be expected to pull up maps, to query them, to create simple maps, to quality check data, to collect spatial data, to listen to the direction of the biologists in kind of putting together a program of data collection. So we are all expected to be proficient with GIS at the user level, and that's the idea behind this class, is we're getting proficient with the user level, right? And so it's something that's integrated into your job. Just like nowadays we don't have a typing pool of people that type reports for us because we all know how to type, but back in like the 60s, you wouldn't type your own reports up because you wouldn't know how to type. You would handwrite things and you'd give it to the typist, and the typist would type your report up. Okay, so it's a modern world. We all do GIS, and I just wanted to quick touch on that there are some certifications. This is the GISP one. It stands for GIS Pro, and that's a professional certification for people working in GIS for many years. So you can't get it right out of school. I think you have to have at least 3 years of experience. It's like 3 to 5 years on the job experience working in GIS before you would look for that. So when you're coming out of school here, there's not anything in specific that's going to make you stand out, besides actually what you know how to do. And so when you write up your resume, definitely highlight that you took a GIS class and that you're proficient with this software, and here's some of the things you can do in it. And for an entry level, that's what you're going to rely on. And most jobs don't require you to have a certification of any sort. Often if somebody's going to go and work freelance and do GIS stuff on a contract basis or have their own business, they want something else to have them kind of stand out, that I actually am qualified and they've already worked in this profession for multiple years. Then they'll go for a GIS Pro certification, and basically you do a bunch of work, show a bunch of portfolios, and sit for tests that cost money, and that's how you get your GIS Pro certification. But at this point, while you're in school for your two-year degree, I would be focusing on your technician skills and getting strong with the data, okay? And working with data, collecting it in particular. We're going to pause this section here, and we will start talking about ethics next. So our next segment is going to be looking in section 1. We're going to talk about some of the ethics of being a GIS professional, of working in this way. So I will see you soon.